moving on to our next story. Is there life on Mercury? I don't know. Possibly in the planet's craters, a study reveals. So, Mercury, first planet from the sun, gets pretty hot up in there. Many people would believe that there is no possible way that life could exist on that planet. No way that that life could then evolve into anything more special. That basically you're just kind of just waiting, waiting to see if there's signs of life in further places on the moons of Jupiter and Saturn, or even on Mars. But not many times do we talk about Mercury as a source of life because there are many factors that would point to it not happening. Scientists at the Planetary Institute have uncovered compelling evidence suggesting the potential for life on Mercury, particularly at its North Pole. Using images from NASA's Messenger probe, the researchers discovered features that appear to be salt glaciers within Mercury's Radicelati and Eminescu craters. Unlike ice formations on Earth, these glaciers would consist of salt compounds that trapped volatiles such as water, nitrogen, and carbon dioxide. Three things that make up, well, it's particularly nitrogen, things that make up most of our atmosphere and most of the environment around us, especially with water. The majority of our planet is just water and a lot of carbon dioxide, C2O or CO2, sorry. Um, So within these glaciers, there are some of the building blocks of life. And I've talked about before the K2-18b planet where we found particularly not only just water molecules in the atmosphere, but we also found other organic molecules that can only be created by life. I want to say it was, I don't remember. I'd have to look that up again. But so we're able to see on different planets these things inside of the atmosphere. However, we didn't really expect or didn't have concrete knowledge of, I think is a better way to phrase it, of something similar happening to a planet such as Mercury, which is so much closer to the sun than we are. So let's talk about the origin of these glaciers made of salt compounds on the surface of this planet. Formation of the glaciers is attributed to the impact of space rocks on Mercury's surface. The impacts penetrated the basaltic outer layer, releasing the volatile, rich compounds from beneath the surface. Mercury's extreme temperatures, reaching up to 806 degrees Fahrenheit or 430 degrees Celsius during the day, have since caused the evaporation of these compounds. It gets hot and heavy up there. However, the remnants of the glaciers are identifiable through Earth-like geological features. Now, let's talk about habitable conditions. We'll continue on with the article. Quote, these Mercurian glaciers, distinct from Earth's, originate from deeply buried volatile rich layers, or VRLs, exposed by asteroid impacts. Our models strongly affirm that salt flow likely produced these glaciers and that after their emplacement, they retain volatiles for over 1 billion years. Said study co-author Brian Travis. This comparison sparks the theory that subsurface areas on Mercury, shielded from the sun's intense heat, might harbor conditions conducive to extreme forms of life. So there are certain molecules and certain things that can survive in very precarious situations, many types of bacteria or viruses and that kind of stuff that we're more so familiar with. But let's continue on. So, specific salt compounds on Earth create habitable niches even in some of the harshest environments where they occur, such as the arid Atacama Desert in Chile, said study lead author Alexis Rodriguez. This line of thinking leads us to ponder the possibility of subsurface areas on Mercury that might be more habitable than its harsh surface. So, beneath the surface, it might be a little bit better for life. These areas could potentially act as depth-dependent Goldilocks zones, analogous to the region around a star where the existence of liquid water on a planet might enable life as we know it, but in this case, the focus is on the right depth below the planet's surface rather than the right distance from a star. Because if it's on the surface, it's immediately going to get burnt up. And to our knowledge, we do not know very many forms of life that could survive in that environment. But first, before we go on, I want to talk a little bit about the Atacama Desert, because this thing is basically what they would call hell on earth. You can kind of see it. The Atacama Desert is a desert plateau located on the Pacific coast of South America in the north of Chile, stretching over a 1.6 thousand kilometer or 990-mile strip of the land west of the Andes Mountains. It covers an area of about 105,000 square kilometers or 41,000 square miles, which increases to 128,000 square kilometers or 49,000 square miles if the barren lower slopes of the Andes are included. The Atacama Desert is the driest non-polar desert in the world and the second driest overall, behind some specific spots within the Mercury dry valleys. It is the only hot, true desert to receive less precipitation than polar deserts and the largest fog desert in the world. And a fog desert is a type of desert where fog drip supplies the majority of moisture needed by animals and plant life. The area has been used as an experimentation site for Mars expedition simulations due to its similarities to the Martian environment. Yeah, so this thing is pretty rough. I mean, you can just see right here. I mean, it's beautiful. See these places, all of these different things right here. They got a couple observatories there. They got some animals there. That's on the coast. Yeah, so this place is pretty extreme, but they do have some observatories here, which kind of look cool in that barren wasteland. Back to the article. The research challenges the notion of Mercury as a planet devoid of volatiles. It suggests that volatile rich layers, or VRLs, are potentially hidden beneath the planet's surface. Quote, a central mystery concerning Mercury revolves around the genesis of its glaciers and chaotic terrains. What mechanism was responsible for the formation of VRLs? In our research, we introduce a model that integrates recent observational data to address this question, said Rodriguez. Notably, quote, we examined the Borealis chaos located in Mercury's north polar region. This area is characterized by intricate patterns of disintegration, significantly enough to have obliterated entire populations of craters, some dating back approximately 4 billion years. Beneath this collapsed layer lies an even more ancient cratered paleosurface, previously identified through gravity studies. The juxtaposition of the fragmented upper crust, now forming chaotic terrain, over this gravity-revealed ancient surface suggests that the VRLs were emplaced atop an already solidified landscape. Challenging long-held theories. Continuing on. Rodriguez said that these findings challenge prevailing theories of VRL formation that traditionally centered on mantle differentiation processes, where minerals separate into different layers within the planet's interior. Instead, the evidence suggests a grand-scale structure, possibly stemming from the collapse of a fleeting, hot, primordial atmosphere early in Mercury's history. This atmospheric collapse might have occurred mostly during the extended nighttime period when the planet's surface was not exposed to the sun's intense heat. Very interesting. Continue on, our last little thing. These insights were made possible through the use of sophisticated models and detailed analysis of observational data. All right. So here is the study right here. I'll post this down in the comments, but if you do have time, read it out because they kind of go through it right here where all of this stuff actually is and kind of what they believe is making it up. Now we have little Miss Carmela joining the show. Up and walking around. She's been sleeping for a little while, but now she's up. Yeah, right? Good girl, lay down. All right, now she's getting in her bed. Good girl. You're a good girl, Carmel. Lay down. I'm just recording a podcast. Good girl. You're doing good. There she goes. Nice. I don't know why sometimes she doesn't want to sleep in her bed. I mean, it's got a blanket in it. It's got the cushion in. Like right now, she has her head and arm on the outside of it. It can't be comfortable. Earlier, she was sleeping on the floor, which not comfortable at all. But we'll continue on. So in this study, kind of talk about the basically what that article was talking about, but this goes way more into depth. Right here. Boom. November 17th. Boo, 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 boo. Very, very, very cool. So the possibility of life on Mercury, I'm going to say right now, not very likely. I would say the chances are pretty low because it is a very, very tough environment, obviously because of the temperature. Um, Also because you have a constraint where you have to be underneath the surface of the the surface, right? Underneath the surface of the planet. So you have to be underground in these salty glaciers. And that's potentially where life would be. So it's not like there's underground water per se, like we would describe it. It's more glacier, so it's more frozen in a sense. But because of the vast temperature differences on the planet, there could indeed become a different uh existence of life that could survive that, such as tardigrades, which can survive in the vacuum of space. I think they brought them to the International Space Station as well. But they're a very small life form that can survive out in space. High temps, low temps, they're very sturdy, I'll say. But we'll keep an eye on this story. Maybe we'll come back to it, but I'm not thinking that we're gonna find life on Mercury anytime soon. I could be wrong. I may be wrong. I don't think I'm wrong, but I could be, right? You would think.